Assalamu alaikum. Hope you all are fine. In this video, we will learn about the preparation of phenols. So, firstly, we will discuss about the relationship of sodium salt of benzene sulphonic acid with the sodium hydroxide. So, as you can see in the below reaction, there is a benzene sulphonic acid on which benzene is a closed ring on which the sulphonic acid is attached. So when it will react with the sodium hydroxide and along with the water molecule, it forms sodium benzene sulfonate. Why it forms the sodium benzene sulfonate? Because in the sodium sulphonic acid, the sodium from the base, that is sodium hydroxide, sodium positive ion will react as a electrophile, and it will replace the hydrogen from the sulphonic acid on benzene. So when the sodium that acts as a strong electrophile as compared to hydrogen, then it will replace the hydrogen and attached in place of hydrogen and form sodium benzene sulfonate. And the other is when it react with the sodium hydroxide, fused sodium hydroxide, it forms a sodium phenoxide because sulfur dioxide will release, and as a result sodium phenoxide forms. And then the sodium phenoxide when react with the acid or water molecule in the presence of some salt, that is sodium chloride. And why we use acid? We use acid to have hydrogen positive ion or hydrogen that acts as a proton, and that can replace the sodium ion with hydrogen. And when this hydrogen or proton will react with sodium phenoxide ion, it will form a alcohol, that is phenol. So phenol, as you can see in my previous lecture, we have studied the phenol, its naming and nomenclature and structure. So this is the phenol in which a benzene ring on which an hydroxyl group is attached. So this is the reaction of sodium salt of benzene sulphonic acid with sodium hydroxide. And the other is base hydrolysis of chlorobenzene, that is also known as Dows method, in which the chlorobenzene, the chlorine atom that is attached on the benzene ring it will known as chlorobenzene, and then it will react with the base because it is a base hydrolysis, and we use sodium hydroxide as base with 623 Kelvin heat and temperature, along with the pressure, that is 300 atmospheric. And we get the sodium phenoxide ion, that is a temporary intermediate formation with the byproduct, that is salt, sodium chloride and water molecule. And then this sodium phenoxide ion react with the acid because uh, it will have to replace the sodium with the hydrogen to form a phenol as a byproduct. So this is the base hydrolysis of chlorobenzene, that is also known as Dawes method. And the other is acidic oxidation of cumene. So cumene, as you can see, the first compound on which there is a benzene ring, and on which the secondary propane or secondary carbon of the propane is attached with the ring carbon. So this is known as cumene, and we will give the acidic oxidation of cumene. Acidic oxidation means the addition of oxygen, so we will add oxygen. We will react the cumene with the oxygen molecule at some temperature, that is 100 to 130 degrees Celsius, and the product will form, that is a temporary compound in which the secondary carbon that is directly attached with the benzene carbon will attach the oxygen molecule. So then this oxygen molecule has one lone pair and two electrons that will further react and attach the hydrogen proton, and this hydrogen proton will gain the electrons from the oxygen molecule, oxygen atom, and forms a bond. And because of this bond formation, oxygen will get positive charge on it, and then when this compound that is unstable, to gain its stability, the oxygen will break the bond between oxygen to oxygen, and the water molecule is released. And the other compound that forms has a oxygen that has positive charge, because it gives its electron to the other oxygen, so it will have a positive charge. And when it rearrange itself, it forms the first compound, that in which the carbon has a directly bond with the carbon with carbon of benzene ring. And after replacement or after a rearrangement of the compound, the oxygen that has positive charge will directly attached with the carbon of benzene. So this will forms the arrangement in which the water molecule attack on the carbon that has positive charge, that is also known as carbocation. And it will then forms a bond with the carbon and oxygen. Then the oxygen will get positive charge. And when the hydrogen will remove or deprotonation occurs in this compound, the carbon that has a bond with the oxygen atom, and then this oxygen will have two bonds with the hydrogen. And from this point, the hydrogen will remove as a proton, and we have the hydroxyl group. And to completely stabilize, or to get the final product, that is phenol, we will get the phenol after the protonation of this compound. So when the protonation occurs, we have our final product, that is a phenol. And is like this. And there is a benzene, and on that, this oxygen will gain the proton and forms a phenol. And when this oxygen will gain the proton, the bond between carbon and oxygen will break, and form a alcohol, that is a secondary alcohol. So this is the secondary alcohol after the protonation of this compound. So our final product is phenol, and we get the final product. And the other is hydrolysis of benzene diazonium chloride. So basically, hydrolysis of benzene diazonium chloride will take place as aniline, the benzene that has nitrogen on it, and it will known as aniline. And when it react with the sodium nitroxide and HCl, that is hydrogen chloride, in the presence of some heat, that is 273 to 278 Kelvin, and it will form 1 chloro 2 phenyl diazine. And then it further react with the copper cyanide or silver cyanide, it forms a benzonitrile. So this is the hydrolysis of benzene diazonium chloride. So these were some uh, preparation of a phenol, in which some compound will react in certain condition and provide our final product, that is phenol, along with some byproducts that will be water molecule or some salts. So these are the preparation of phenols. Thank you so much. Take care. Allah Hafiz.